So in this video I will show that this function is continuous. Since the or here we will bestow it with the usual topology and this as well. So we have a necessary and sufficient condition for a function to be continuous, that is inverse image of every open set must be open. So let's take any arbitrary open set. Let me take A to be open interval a comma b. Okay, so we have to, by this criteria we have to show that inverse image of this open set is open. So there are various cases. So we know that this is your modulus function. So your modulus function, and the very first case goes like this, that is if a is less than 0, b is less than 0. In that case, what will happen to the inverse image of this open set? Since this is open in usual topology, because the basis of usual topology of OR, in case of OR, is the class of sets of this nature. That means that basis of OR under usual topology is generated by this kind of sets, open intervals. So if a is less than 0 and b is less than, what will happen to the inverse image of this? Inverse image of this, we know that that is just the set of real numbers from domain such that f of x belongs to open interval a comma b. But we know that f of x, that is modulus of x, is non-negative quantity, but on the other side this is an interval which contains only negative entries. That means there does not exist any real number which is going to satisfy this inclusion. So that means this is empty set. It's empty set because your AB is here. AB is here. Sorry, we are not supposed to take that. That means AB means a set from the codomain. That means if this is your A, this is your B, B is greater than A, B, and this is your A. That means for what values of x this modulus function is going to lie on the negative side. You know that modulus function is always greater or equal to 0, but this shows that if there exists any element in this set, that means if it is non-empty, that means modulus is going to be negative, which is not possible. So this is the reason this is empty set. But we know that in topology, in usual topology or with usual topology, empty set is always open as well as closed. So that means inverse image of this open set is open in this case. So it is clear. For this case it is clear. Now case 2. Case 2 goes like this. If A is negative, let's take A negative and B is positive. That means this is your modulus. A is negative, that means this, and B is positive, that means B is going to lie here. B is going to lie here. Since we have to check all those real numbers whose image is going to lie in this interval, that means we have to check inverse image of this set. That is set of all real numbers such that f of x should lie in this A. A is your AB interval. A is your AB interval. That is equal to. Now, for what values of x, f of x is going to lie in this? For what values of x? I suspect it is going to be minus b to b, because let's take an example, you will get thing is done. That means let's take inverse image of minus 5 to 2. That means set of all those real numbers such that mod x belongs to minus 5 comma 2. For what values of R, for what values of x from R, modulus lies in this. That means if we are going to take any number on the right of minus 2, any number, let's take x equal to any number on the right of minus 2, That means let's take some minus 1. If we are substituting here minus 1, modulus of minus 1 is plus 1, plus 1 lies on this. Like that is value of minus 1, that will come here. Okay, so if we are going to take 1.5, negative 1.5, that's again positive, that is 1.5, and 1.5 lies in this. This is the reason. But on the other side, if we are going to take any number on the left of minus 2, yeah, if we are going to take minus 2, if x is minus 2, modulus of minus 2 is plus 2, and plus 2 does not belongs to this. That means minus 2 is not going to lie in this set. That means this will include only these numbers, that is minus 2 to plus 2. That means all those real numbers which are greater than minus 2 and which are less than plus 2. Okay, so if we are going to minus 3 is below minus 2, and modulus of minus 3 is plus 3 is not going to lie in this. This is the reason we are leaving minus 3. Every number on the left of minus 2 are not going to lie in this. Okay, so this is second case. Above all, this is open interval, this is open set, and inverse image of open set is again open. We know that this is open in usual topology. Case third is here A is negative, but B is positive. Here B is negative. Now third case must be B is positive and A is non-negative. In this case, what will happen? That means inverse image of open set A comma B, but A is non-negative. What will happen? That means we are looking for those values of x whose post image is going to lie in this. That means A is non-negative. That means from here to, if this is A is going to start from here onwards, and B is also somewhere here. Okay, so if we are going to draw the graph of modulus of x, what will happen? We are supposed to take which values of x we are supposed to take, so that modulus is going to lie in this. That means modulus is going to lie in this. That means we can take all values. We are supposed to take all values from, we can take all values from minus B to minus A, union A to B. How this is possible? You can check everything from the graph. That means if we are going to take a non-negative, for example, since if A is here, okay, so yeah, B is here, okay, here it is minus B and here it is minus A, here A is here, okay. If we are going to take any number from this to this, for example, let's take this number, what will happen to the corresponding value, that is modulus values of x, that is here, and that lies in this range, A to B. This is your A, this is your B. That means this is going to lie in this range. Okay, if we are going to take this value, again this is going to lie in this A to B. If we are going to take here, somewhere here, so again that is going to lie in this. Okay, so it is clear from the figure that inverse image of AB is minus B minus A union AB. This is open interval in usual topology, this is open set in usual topology, this is open set in usual. Finite union of open sets is open in usual topology. So we can say that this is open. So we have proved that inverse image of open set is open in every case. That means in every case we get success to prove that inverse image of open set is open. By necessary and sufficient condition of continuity, it means that this modulus function is continuous. Okay, thank you.